Okay, so let's get going on our spreadsheet model. I'm going to work at a modest pace because I assume that you can pause and rewind if necessary. Now hopefully you've downloaded this file and have it open so you can follow along, because after all that is the idea of doing the example. Now I'm going to cover this in 4 parts. The first part, I'm going to go over the spreadsheet model, explain each section of the spreadsheet and talk about what it does and how it corresponds to the information in our original problem. Part 2, we're going to enter formulas and name cell regions using the define name feature in Excel, which is very, very handy. In part 3, I'm going to walk you through entering the data into the cells and formulas and so forth. And part 4, we will quickly use the solver add-in to have Excel generate a wonderful, quick, elegant answer to a very complex problem. Okay, so let's get going. Now the first part of the spreadsheet to take note of is at the top center. You'll see a row of cells in a sort of a salmon color, and that is the unit cost or cost per shift. You will see all 5 customer service representative shifts that the cost center offers: 6 a.m. to 2 p.m., 8 a.m. to 4 p.m., and so forth. Now below each one of those will be the average daily cost, labor cost, of one customer service representative, or CSR. So each shift will have its average daily cost for one CSR. Over on the very right, in the blue color, if you remember in our problem, management decided that there is just a certain number of CSRs that have to be on any given shift or any given 2-hour period, as you can see there on the left. And that's so that the cost center can maintain a minimum quality of service, because we could have 3 CSRs trying to answer 20 calls a minute, but that's not going to offer very good service. So that column will represent the minimum number of CSRs that management has decided must be on shift during any given 2-hour period that corresponds to the 2-hour periods on the left. Okay, and the purple column in the middle, once we're all done, that will tell us exactly how many CSRs are working during any given 2-hour period, which is fantastic. It's almost magic. Now the large box in the center, those cells will hold binary information, either ones or zeros, and all that does is it tells us, is the 2-hour shift on the left covered by the daily shift that runs vertically? So if the overall shift covers that 2-hour period, we'll put a 1. If it does not, we'll put a 0. But we'll type all that in here in a couple minutes. Now in the light blue at the very bottom, this is actually what Excel is going to generate for us. It is going to tell us exactly how many CSRs to put on each shift in order to minimize our labor cost. So that's what we're actually kind of solving for. And then the pink box in the lower right will tell us our actual labor cost per day in total. So the average cost per customer service rep and the number of reps on any given shift, of course, will add up to be our total labor cost for the day. Okay, so the next thing we're going to do is we are going to define names for certain cell regions. Now Excel has a wonderful feature in it that will allow you to select a cell or range of cells and then give that range of cells or individual cell a unique, intuitive name that's a lot easier to remember than C8 through E8 or something like that. So we're going to give certain regions of our spreadsheet names so we can then use those names in formulas and in the solver and things like that. So let's go ahead and get started on naming our regions. So the first region we're going to name is the unit cost or cost per shift line, which is the very top salmon color row. So we're going to highlight C5 through G5. And then I'm going to right click to the context menu. And right near the bottom we have define name. So I'm going to select that. And this will bring up our new name box. Now I have a convention for naming cell regions, so I'm going to stick with that. So I'm going to call this cost per shift. Now the scope drop down box, in this you can decide, do you want this name to permeate your entire workbook, or do you want it to only work for this sheet? So that way you could reuse that name on different sheets. Since I'm only using one sheet in this demonstration, I'm just going to select workbook and leave it at that. So I'm going to go ahead and hit OK. Now, that row of 5 cells, C5 to G5, we can now refer to that row using cost per shift in any formula or anything like that. And we'll see how that plays out here in a minute. Okay, so we have a few more to do. So I'm going to go over to the blue column on the very right. I will highlight that column, right click, select define name. I'm going to call this minimum needed. Minimum needed. And I'll leave scope to workbook and click OK. Okay, the next range we're going to do is the number working, which is the very bottom, the light blue color there. Right click, define name, and we'll just call this number working. 3 more to do. Now the next thing we're going to do is the very large region here in the middle that extends from C8 all the way down to G17. Right click, define name. We're going to call that shift works time period. Shift works time period. Go ahead and click OK. Now in the bottom right, which is the one in the end we're going to be most concerned about, our total costs. We're going to right click that, define name, call it total cost, and then one more is the purple column. Select that, right click, define name. We're going to call this total working. Okay, so in just a couple minutes there, we have defined different areas of our spreadsheet using the define name feature in Excel, and that way we can use the name instead of the cell region in formulas and any other manipulation we might want to do. Okay, we do need to enter a few formulas in the spreadsheet. And luckily, we only have to enter 2 because we can actually use the autofill feature. So in H8, which is the first cell in the total working column, we're going to enter a formula. And it will look like this. So it will be equals sum product. And Excel will go ahead and guess what you want to do, and that's what we want, so sum product. Now what this does is it will take an array of cells, multiply it by a corresponding array of cells, and then sum all of that up. So I'm not going to go into a whole lot about what that does, but if you Google sum product function, it will tell you exactly what it does. So basically we need 2 arrays. So the first array we're going to do is the shift covers time period row to the left of that. So that's going to be our first array. And we'll put a comma. Now our second array will be number working. And you can see Excel guesses you want that. And we'll close the parentheses. Now what is this going to do? Let's make sure we understand what's going to happen. The sum product will take one array, multiply it by another array, or matrix if you prefer, and then sum that up. So what this is going to do is it will take the shift covers time period row right here at the top. It will multiply that by the number working row down below, and then it will tell us how many CSRs are working during that 2-hour period from 6 a.m. to 8 a.m. Pretty cool, huh? So we're going to go ahead and hit enter for that. There's no data in the spreadsheet now, so it'll say 0. Now the cool thing is we can just, since we want all this information in total working, we can just select that cell and drag down, and it will fill it in. So if we look at the next one, it says C9 to G9 number working. Next one is C10 to G10 number working, and so forth. So just using the fill down feature in Excel, it changes the reference cells there at the beginning, keeping the number working array the same. So it moves down a row each time in the shift covers time period, but maintains the number working row there at the bottom. So that's that. We have one more, and that's going to be our total cost of labor per day. And that would be equals, again, sum product Now what do you think is what's going to go here? What row in our spreadsheet tells us how much each shift costs per CSR? Well, that's our cost per shift up here at the top. So our first array will be cost per shift, and we'll select the tag there. And of course, we need to multiply that by the number of CSRs that are working. If you remember, that is our blue at the very bottom here. So we're going to multiply cost per shift by the number of CSRs working. So number working, select that, close parentheses, and enter. And as far as formulas go and naming regions, that's it. We did it in 2 or 3 minutes, okay? So part 3, we're going to go ahead and enter in some numbers, which will make everything start to look a little bit better. So we're going to go ahead and enter our shift data in the top row. So the first shift was $170 per CSR. The next one was $160 per CSR. 175, 180, and 195. Okay. Now just remember that the shifts tend to get more expensive as the day goes on because there are shift differentials for evening and overnight workers, which is actually fairly common. Okay, we'll go over to the minimum CSRs needed. And again, this was provided to us by management, who went back and looked and said we at least need this many in this given 2-hour period. So we had 48, 79, 65, 87, 64, 73, 82, 43, 52, and 15. So what we're telling Excel is that, for example, from 8 p.m. to 2 p.m., we cannot have less than 43 CSRs on duty. That's just the absolute minimum that we're willing to accept. So that is that row there. All right, so we're going to go ahead and go to our middle section, our shift covers time period. And remember, this is either 1 or 0, 1 being yes, 0 being no. And the question is, does the shift column we're in cover the 2-hour period to the left? So the 6 a.m. to 2 p.m. Well, that covers 6 a.m. to 8 a.m. Same thing for the next one, and the next one. And then that shift is over for the day, so the rest are all zeros. Okay, so we're going to do the same thing for the 8 to 4. 6 to 8 is not covered there, but we're covered from 8 to 10, 10 to 12, 12 to 2, and 2 to 4, and then not for the rest of the evening and overnight. So you're smart, you can see how this works. I'm just go ahead and type them in. Okay, one more. Okay, so now we have our cost per shift, we have our minimum number needed, and we have our shift covers time period, yes or no. And from here, we're ready to get into the solver. Okay, so let's go ahead and get the solver magic on track here to solve our problem. Now, I do want to make sure you have the solver add-in installed or loaded into Excel, so I'll walk you through that real fast. In 2010, at least, it's under the File menu. You go down to Options. In the Excel options, you will see Add-ins. And at the bottom of the Add-ins screen, you'll see where it says Manage Excel Add-ins. So you go ahead and click Go. And then an add-in box will pop up. Now I have many other statistical add-ins in here. But you want to make sure at the very bottom you see it will say Set Solver Add-in. Make sure that's checked. Of course I have mine checked. If yours is not, go ahead and check it and click OK. Alright, now our solver add-in is loaded into Excel and we are ready to solve. Now to access that, it's under Data, and then over on the right hand side under Analysis you'll see the solver. So let's go ahead and click that. Now this can be a little intimidating at first, but once you do it a couple times it's fairly self-explanatory. Now, where it says Set Objective, remember, our objective here is the lowest possible labor cost. So our objective is sort of our target. In previous versions of Excel, it was called Target Cell, but that's the one we want to hone in on. Now the great thing is, because we've named it, we can just use the name, which is Total Cost. Now if you remember, that was the pink at the very bottom right of our spreadsheet. So that's what Excel is going to really focus in on. Now we are wanting to minimize that, so we select the MIN for minimum. Okay, now below that we have by changing variable cells. Now what we have to do here is tell Excel what do we want Excel to figure out in order to create the lowest possible cost. So, of course, we want Excel to tell us what's the optimum number of employees per shift that covers our minimum requirements, but does so at the lowest possible cost. So we're going to have Excel manipulate and change the number working, which is the light blue at the bottom of our spreadsheet. So Excel is going to figure out the best combination or the best set of numbers in the bottom of our spreadsheet to make our cost the lowest. So if you remember, we named that light blue row number working. And that's that. Now we do have to add a couple of constraints, or I guess in this case one constraint, and that is our total working, the purple column, has to be greater than or equal to the minimum number. Because remember, we cannot go below the the number of CSRs in the blue. So we're going to add a constraint. Okay. And remember, we named these two, and this is total working must be greater than or equal to minimum needed. So the total working has to be greater than or equal to the minimum needed. We'll go ahead and click OK. Now there are two more things we have to do here real quick, and then we're pretty much done. You want to make sure the make unconstrained variables non-negative is checked. And basically all that means is that in this sort of problem, we cannot have negative people on shift, which should make sense. We can either have 0 or more, but we cannot have negative people. And then in select solving method, you want to click on that arrow and select simplex LP. And basically that just means simplex linear programming. Okay? And that is pretty much it. So if we've done everything right, we'll go ahead and click solve. Okay, so solver found a solution, as it tells us. Now we can keep solver solution, or we can restore what we had before, but we're going to go ahead and keep the solver solution. Go ahead and click OK. Now let's look at what this did here in one click. It still amazes me every time I do it. In one click of a button, Excel was able to tell us exactly how many CSRs to have on shift, on each shift, that one met our minimum requirements of CSRs needed, and two at the lowest possible cost. So if we look down at the blue row at the bottom, Excel figured that out for us. So it's telling us that we need 48 CSRs on shift from 6 to 2, 31 on shift from 8 to 4, 39 on shift from noon to 8, 43 on shift from 4 to midnight, and 15 on shift from 10 p.m. to 6 a.m. Now if we look at the total working rows, the purple column, that tells us how many CSRs will be working during any given 2-hour period. So you will see from 6 a.m. to 8 a.m. we have 48 working, which should make sense because if we go down to the bottom row, there's only one shift on duty at that time. It's the 6 to 2 p.m. shift. Excel told us we need 48, so 48 times 1 is 48. Okay. Now, in terms of the 8 to 10, we're going to have a total of 79 CSRs. So, of course, we will have people from the 6 to 8 shift, and then we will have some new people coming in at 8 that will add to that 48 total, and so on and so forth. So you can see the distribution of CSRs on shift during any given 2-hour period by the total working column. And it would tend to make sense that from 12 to 2, we're going to have the most CSRs on shift. That's the busiest time of day, according to our past data. And a lot of people call in on their lunch breaks if they have an issue they need to work out or something like that. So that's a very busy period for the call center. Also, that's when people in the call center will probably be taking their lunches. So we will have to cover, CSR lunches during that time period as well. So that should make intuitive sense anyway. Okay, well, I'm going to wrap this up, the video part at least, here, and point out that in the lower right-hand corner of our spreadsheet, our total labor cost per day will be $30,610. And that $30,610 is the absolute lowest possible cost that we can staff the call center given the minimum CSR constraints we had and the cost per shift. And that is how we solve and staff a call center using past data, current wages, and use Excel to tell us exactly how many we should have per shift. Great. Hope you enjoyed it.